All right, this is going to be the second video about transformations. And before we even start this one, there's a couple things that I would like to tell you or you to be familiar with. So, the first thing that I would say is important to understand is that timesing something by 2 is the same thing as dividing by a half, or dividing by 5 is the same thing as timesing by 1 over 5. Whenever you put like 1 over something, it kind of changes like the times and divide. It's just kind of difficult to explain. This is important to understand though. So like if I say, and I'll be doing tables, right? And so if I say like times by a third, you need to realize that that's the same thing as dividing by 3. So that is kind of important to know before we even do any of this. Another thing that I would say is important to understand is that imagine I had 1 over 1/2 like this. You could kind of imagine this as 1 over 1 over 1/2. And when you have a fraction on the bottom, you can bring it to the top. So I still have my 1 over 1 here. You can bring that fraction to the top and flip it and change it to a multiply. So when I say flip it, I mean switch the 1 and 2's locations. So now it's 2 over 1. So this is actually 2. So if you see like 1 over 1/2, please realize that it's the same thing as 2. Okay, you'll see why this is important when we get to the horizontal changes here in a second. All right, this is transformations 2. This is going to be about stretches or compressions. The first thing that I would really try to know is that stretches or compressions happen. Stretches, compressions, they happen when there is a, oh goodness, they happen when there is a number multiplying the f of x. Notice this 2 is multiplying. So that means it's going to be a stretch or compress. You kind of have to determine which one, and I'll show you how. Notice that next one, this 1/2 is multiplying. Over here on this side, this 1/2 is multiplying times that x. This 2 is multiplying times that x. So whenever it's multiplying or dividing, or sorry, just multiplying, it's going to be a stretch or compression. The way you tell which one is which, well, it still works like the previous video where if the number is outside, so look at example 1 here, the number is outside, that means it's vertical. It still means, outside still means vertical. The only difference between this video and the last video is, last video we were adding or subtracting numbers, which are shifts. When it's multiplying, they're stretches or compressions. So if it's vertical, if it's outside, it's affecting the y, so it tells the truth. Remember, it's the x's that lie, that do the opposite. Y tells the truth. So if you see 2 times f of x, that means you're multiplying something by 2. And in terms of determining if that's a stretch or a compression, if you took a ruler and you multiplied the length by 2, you stretched it. So multiplying something by 2 is a stretch. And in your table, if it affects the y, you put it next to the y column, and you actually do what it says. So I'm going to times all of these numbers by 2 to get these new numbers. So that's going to look like -4, 4, -4, 4. And then when I go to graph it, I'm going to use the outermost coordinates again. So -1, 4. Oh, no, it's a -4, sorry. -1, -4, 1, 4, 3, negative 4, 5, 4. So notice when I connect these dots, it took my original parent function and stretched them out a little bit vertically. All right, so looking at this next one, when I look at this, I see the 1/2 right here. It's outside, so that tells me instantly that it's vertical. And then in terms of if it's a stretch or a compression or a shift or what is it, well, if you look at that 1/2, it's multiplying f of x. So if it's multiplying, it has to be a stretch or a compression. Which one? Well, if I took a ruler and I multiplied its length by 1/2, I would have compressed it. So this is an example of a compression times 1/2. So in my table, it's vertical, so I put it next to my y column. And I'm just going to be taking all of these numbers here and multiplying them by 1/2. So now I've got -1, 1, -1, 1. Then I'm going to graph it using the outermost coordinates. So it would look something like this. When I connect the dots, you can kind of see that it got shrunken vertically. So it's half as tall as it used to be, basically. All right, now where it gets really weird. This right here is a concept that is very, very difficult, A, to explain, and B, to understand. So first thing I would say is when there is a number multiplying that is inside the f of x part, it means it is horizontal, and it means it's either, since it's multiplying, it's either a stretch or a compression. Now, the way that they want to word this, the way that they're talking about it is they're giving you this equation by default, f of 1 over b. And then they're saying that they're going to let b equal 2 or something. So remember in my previous video I said x lies about everything. Well, here's why. Because when you put in a factor of 2 here, it gets thrown where b is currently. And so it changes from being times by 2 to being times by 1 over 2, which is kind of like the opposite. Timesing by 1/2 is the same thing as dividing by 2. So in my table, when I go to fill in my table, I'm taking whatever is here, this 1/2 times x, and I'm doing the opposite. I will not be timesing by 1/2. I'll be dividing by 1/2. Well, dividing by 1/2 is the same thing as timesing by 2. So I'm taking these x values, I'm going to times them by 2, and then these would be my new coordinates. Now, if I times something by 2, like if I took a ruler and I timesed its length by 2, I would be stretching. So what's going to happen here is it's going to take this parent function and it's going to pull it apart. It's going to stretch it out by a factor of 2. So let's plot these new points. And we're going to run out of room here, but that's okay. We'll say it's way over here or something. So this thing looks like this. So you can see it kind of just pulled that original parent function apart, stretched it out. Main takeaway here is whatever you see here, do the opposite. So if it's telling you to times by 1/2, divide by 1/2. And like I said at the very beginning of this video, dividing by 1/2 is the same thing as timesing by 2. Okay, last example. I see f2 of x. It is inside meaning it has to be horizontal right from the start. Now, when it's horizontal, it lies and it's opposite. So the original looks like 2 times this. Well, that means in your table, you're not going to times by 2, you're going to divide by 2. And dividing by 2 is the same thing as timesing by 1/2. So when I do this, I'm going to be timesing everything by 1/2. So that's going to look like this. Negative, I'll use decimals. Or you could use fractions, it doesn't matter. All right, so these coordinates are what I'm going to use when I go and apply transformations to my parent function. So negative 0.5, negative 2, 0.5, positive 2, 1.5, negative 2, 2.5, positive 2. So as you can see, this thing basically shrunk. It got squished. So when I take a ruler and I shrink it down, I'm compressing it. So this is a compression. By a factor of 1/2. All right, quick recap, because I know that was kind of confusing. If there is a number, we'll do this down here so we don't confuse anybody. If there is a number in front or mainly just outside of that f of x, it means it's vertical. And when it's timesing, that is what makes it a stretch or a compression. If it's vertical, it tells the truth. So 2 times something would be a stretch. Imagine it was like 1/3 f of x. It is timesing, it is outside, so this is an example of a vertical compression. If I took something and I times its length by 1/3, I'm compressing it. Okay, now the weird ones. Imagine it said like f of 5 of x. This is 5 times. It is inside that f of x part, so inside means it is horizontal. It's got to be either a stretch or a compression because it is multiplying. And since it's inside and it's horizontal, everything is opposite. So instead of timesing by 5, you would be dividing by 5, which is the same exact thing as timesing by 1/5. So dividing something by 5 or timesing it by 1/5 is going to compress it. And lastly, imagine it was like f of 1/3 x. Okay, it is inside. It is multiplying. So I know instantly, since it's inside, it's got to be horizontal. It's multiplying, so it's got to be a stretch or a compression. Well, since it's horizontal and that means it's inside, I do the opposite. So instead of timesing by 1/3, I divide by 1/3. Dividing by 1/3 is the same thing as multiplying by 3 or 3/1 if you thought about it. So if I times something by 3, I am stretching. I hope that helped, and I hope you didn't get too confused.